Good morning, students. We are discussing chapter 2 electrochemistry. In last class, we have discussed about the galvanic cell. Here there are two half cells and those are connected by a wire. There is a flow of current, generation of electricity. In today's lecture, we shall discuss following topics. Standard potential of electrode and cell representation, ECS electrochemical series, and SHE standard hydrogen electrode. And then we will learn about the Nast equation, applications, and numericals. Let's start. In today's lecture, we will talk a lot about the potential. Before going further, we have to understand simple electrode potential. What is electrode potential? In 11th or 10th standard in physics, you have learned about the potential, where there is a point charge. When it is taken from a reference to a particular point in electric field, the work done is equal to the potential. But here in electrochemistry, we are talking for the potential. Then potential, actually, in last lecture we have discussed about the cell. In a cell, there are two half cells. First one, oxidation half cell, and second, reduction half cell. In both of the case, what happen? Atoms from the metal, for example zinc electrode, this one is the zinc electrode, atoms come into the contact of particles of the solution, ions of that metal. Now there are three possibilities here. When it goes to the metal, then metal loses electrons, and second, ions accept electrons and they deposited on concerned metal electrode. And the third condition, it is also possible that neither losing nor gaining of electron. But potential is generated when either there is a losing of electron or gaining of the electron. So we can define the electrode potential as the tendency of an electrode, that is a metal rod, to either get the electron or lose the electron. Same we can read in definition. It is the tendency of an electrode to lose or gain electron when it is in contact with ions. On the basis of these two half cells, electrode potential may be of two types. First one, electrode potential when oxidation takes place, that is called oxidation electrode potential. Here it is a metal, it is losing electron, therefore it is oxidation electrode potential. It will take place at the anode. Similarly, there is a reduction electrode potential when an electrode tends to gain electrons. Here from the solution, copper ions takes the electrons, they are being reduced, therefore it is called the reduction potential. In overall electrochemistry, when you solve the numericals or analyzing any data, then you will find the standard value of potential in the form of reduction electrode potential only. There will be no oxidation electrode potential. One more thing that is important to remember, that reduction potential and oxidation potential both are numerically same, but their signs are opposite. Now it is clear what is the electrode potential. Then we shall discuss about the standard electrode potential. Generally, electrode potential changes with the temperature and concentration and various other factors. So we use a term standard electrode potential. Standard electrode potential of any metal electrode is calculated with respect to a standard hydrogen electrode. A standard hydrogen electrode. It is one important factor here, that is called SHE. Many times it has been asked in the board exams. And actual what is the SHE? Its electrode potential is taken as 0 when three conditions are maintained. First one, very important, 1 molar concentration. It means ion concentration is 1 mole in 1 liter, and pressure is maintained 180 atm and 298 Kelvin. When these three conditions are maintained, then hydrogen electrode potential is taken as 0. If we talk about it shape, then here we can see there is a container where the 1 molar acidic solution HCl or H2SO4 is taken, and there is a glass jacket in which a platinum wire is taken for the conduction of electricity, and from one side there is a hole from where pure hydrogen gas introduced into the system. Here there is a platinum foil, and we know platinum has the property of adsorption of gases. It is a tungsten metal. Hydrogen gas when absorbed here, then it is connected in a cell either as an anode or a cathode. Now question arises, how we can calculate standard reduction potential of metal. किसी भी मेटल का स्टैंडर्ड रिडक्शन पोटेंशियल कैसे कैलकुलेट किया जा सकता है? फॉर दैट वी टेक SHE. We connect SHE as a cathode while metal act as a anode. For example, in this cell here we take the zinc metal, and on the right side we take SHE, and they both are connected, and from here we connect a potentiometer and calculate the current flow, and the potential is taken into the V. That will be the cell potential, E cell. Suppose this value is 0.76 volt when zinc is connected with SHE. We will put all the values. E0 cathode, that is of SHE, it is 0, and for anode we have to calculate. Putting all values, we find the E0 cathode as minus 0.76 volt. It is the value of zinc metal electrode. In this way we can calculate any metal standard reduction potential by connecting that with the SHE. Here two things which we have to know, those are very important. Here I have written this sum information in a standard way. It is called cell representation. Here three things, those are very important, we have to note it down, that on the extreme left side we use a metal which is undergoing oxidation. Zinc is going oxidation Zn to Zn2 plus, and then its concentration 1 molar. Here two parallel lines are shown, these lines are salt bridge. Then after we take the SHE H plus, here I have written the reaction which is taking place as the cathode. H plus is absorbing electron which are coming from the zinc and converted into hydrogen gas. This hydrogen gas is evolved here. and from the extreme right side here H plus is converted into H2. This is the oblique sign and it is the concentration of H plus ions into the acid, and for the hydrogen gas it is represented into the bar. Not, it is not a concentration term, it is a pressure term. And this is the electrode which we have taken, inert electrode, platinum. Platinum has two qualities, those are very important. First one, it is inert, and second, it absorbs the hydrogen gas easily. When we calculate standard reduction potential of all metals by using SHE and arrange them in increasing order of their electrode potential, then we get a series. That series is called standard electrode potential. It is calculated with respect to SHE, standard hydrogen electrode. Here I have given some important frequently given electrode potentials in your numericals. For example, lithium has the electrode potential of minus 3.05 volt. These all are in terms of the standard reduction potential. If we have to calculate from here standard oxidation potential, then it will be plus 3.05. But as per the convention, we only take them as the standard reduction potential. So all negative values represent the highly metallic substances. This series is very important. It gives a lot of information about the elements, their behavior in electrical chemistry. For example, by studying this table, simply looking on the values of their standard reduction potential, we can find that which out of the following has the maximum metallic character. Higher the negative reduction potential, more will be the metallic character, and just reverse, more positive standard reduction potential, more strong will be non-metal. Fluorine is the strongest non-metal, lithium is the strongest metal. And at metal there is oxidation takes place. They show the oxidation property, therefore strong reducing agent. Similarly, they show reduction, so act as a strong oxidizing agent. When they both taken in a cell, then above will work as a anode and downward will work as a cathode. By using this series, we can also predict whether an element can remove hydrogen from its acid or not. Here, this is the hydrogen, its electrode potential value is 0, and these all ever metals can displace hydrogen from its acid, but these can't. There are few applications, most of them we have already discussed, like metallic property, anode and cathode, their oxidation behavior, reducing behavior. But there are three important: determination of EMF of the cell. Here it is very important to know what is the difference between EMF and cell potential. When we use this type of cell, then the value comes, that is the EMF, if we have not drawn any cell. But after some time, when we use current from the cell, then its standard potential decreases, and that is called cell potential. It means cell potential is the cell potential when cell is in used, but EMF is the maximum value of cell. And EMF can be calculated E naught. Naught means standard, by subtracting E naught cathode minus E naught anode. It is very important formula, will be used frequently, and the questions will be asked on that. Cathode generally we taken at the right side. This is the anode, and this is the cathode, and this is the anode. It is right hand side and it is the left hand side. When its value, which is calculated by the SHE, is subtracted by the standard anode value, and we can calculate the E naught cell. Second application, feasibility of reaction. It means if we take any two element from this series, whether it will work as a cell or not. So we have to calculate the E cell by using this formula. If it is positive value, then it will work, and if it is negative value, it will not work. If it is 0, then the cell is in equilibrium condition. So for the feasibility, for the making of the cell, it is important that E naught cell should be positive. And one more application, reactivity of metals and non-metals. We can calculate which one more metallic in nature. So higher the more negative value, more will be the metallic in nature, and vice versa. Okay, thank you. In next class we shall discuss about the Nernst equation.